Hey students, this is lesson 122, slope and scale. What we're going to learn here is how changing the scale can affect the appearance of a graph line. It can actually make something look steeper or not as steep. We have a couple of grids here, and I'll just get you started. To graph these, we're going to graph this line. It's linear, but not a direct variation. To do that, let's just make a quick table of values here of x and y. And let's just go 0, 1, actually let's go 0, 2, 4, 6, 8, and get some values there. So over here, y is 2 times x plus 1, so we're going to double 0 and add 1. 2 times 0 plus 1 is 1. 2 times 2 plus 1 is 5. 2 times 4 plus 1 is 9. 2 times 6 plus 1 is 13. We can now see a pattern. We're adding 4 every time we go up by 2 here. So this will be 17. I'm going to graph those values on this first graph, and I get 0, 1, 2, 5, and 4, 9. And I can see I'm already off the grid there. I'm going to go ahead and connect those with a straight line so we can see the graph completely here. There you go. Okay, now I'm going to graph those same points on the second graph, 0, 1, which would be right here. 2, 5, 4, 9, 6, 13, and 8, 17, and draw a line through those. And you can see from this picture that we are graphing the exact same points, but we made this graph appear to be a lot steeper. It looks like the rise, there's a lot more rise per run on that one than there is on this one here. This one looks flatter than that one. And the way we did that is we changed the y-axis scale. We made this scale twice as big as this y-axis. Let's try one more here. We'll use the same points on this graph. It says, let's try and see if we can make it even flatter. And in this case, I'm going to change the x-axis and just see what that does. So what if we had the same scale as the last one? So we're going to go 2, 4, 6, 8, 10, 12, and so on. And then now I'm going to change my x-axis scale. And what I'd like to see is a lot more run for the rise. And to do that, what if we went by 2s here also? So we go 2, 4, 6, 8, 10, 12, 14, 16, 18. Okay, now I'm going to graph the same exact points again. I'm going to graph 0, 1, which is right there. Then I'm going to graph 2, 5, which is right there. 4, 9, which is right there. And 6, 13. Now, when I did this one, I'll draw a line in there. By changing the x-axis scale, what I did is I got the line back so that it looks a lot like this. So changing both axis scales doesn't really change much. Now, let's just try one more here. And you can just watch if you want on this one. You don't necessarily have to put any points on. But what if I keep my original y-axis scale like we had here, but leave my x-axis doubled? Or maybe I even, on this one, maybe I want to change my, well, let's leave it the same there. 1, 2, 3, 4, 5, 6, 7, 8. Now I'm going to graph those points again. 0, 1, 2, 5, 4, 9, and so on. And now check out how steep it's looking. So it looks steeper than any of the graphs I've done so far. So you can really affect the way your graph looks by changing the scales. Now, what in real life, the effect of that is by choosing the graph, you can change the impression you give about a graph. So let's just look at this one problem here about, it says Ava's mother thinks Ava is spending too much money on DVDs. Ava says that since DVDs cost only $10 at discount sounds, the amount she spends does not increase very quickly. So Ava decides to make a graph showing how much the total spend changes as she buys more DVDs. And she thinks if she chooses her scales carefully, she will convince her mother that the amount increases at a slow rate. So we want to make a graph that is really flat. So it looks like we're not changing very much. And the values we're going to use are the DVDs, the cost of the DVDs, so the dollars, that's going to be on the y-axis, and the x-axis is going to be the number of DVDs that she buys. So as the x values go up by 1, the amount she spends goes up by $10. Now, let's pick our values on our axis carefully. So we're going to have our money spent over here, and we're going to have our number of DVDs down here. So let's just stick with going up by 1s for the x-axis for now. And what we want is this to look really flat. Now, to get it to look flatter, remember from on that first problem, the way we got the second one to look flatter is we used higher numbers on the y-axis. So if I went up by, say, 10s here, then at 10 DVDs, it would be $100. That would be right here. So I would get a line that's kind of diagonal through there. I'd like one that's even flatter than that. So what I'm going to do is jump up the amount that I go up by. I'm going to go up by 25. So here's $50 spent. Here's $100 spent. Here's $150 spent. $200 spent. And now at 0, here's my point at 0, 0. My next point, 5 DVDs cost $50. That's right here. 10 DVDs would be $100. And notice what happened? The graph got really flat, and now I think Ava can use this to convince her mom, look, Mom, my graph is hardly going up at all. It's pretty flat, so I'm not spending a lot of money. All right, what I'd like you to do is part B, and be ready to share that with class. If you're Ava's mother and you know something about graphing, what you're going to want to do is to make a really steep looking graph to convince Ava that she's really spending money a lot. All right, and I'll check back with you next time we meet in class.